Welcome children. Assessment worksheet number 15, class 10, subject science. Topic is electricity. Answer the following question. Question number 1 is answer the following question. A charge of 150 coulomb flows through a wire in 1 minute. Find the current flowing through it. You have to find current. So value of Q is given 150 coulomb and time is given 1 minute. So you have to convert a minute into seconds. So 1 minute equal to 60 seconds. Formula is I equal to Q upon T. When you put up the value 150 upon 60 and after the calculate this 15 upon 6 is and that is 2.5 ampere. B. List the factors on which resistance of the conductor depends. Answer is area of cross section. Second, the length of wire. Third, the material of the wire. And fourth, the temperature at in which it is functioning. You can write this or you can left this. So basically on these three, area of cross section inversely proportional, the length of the wire directly proportional, and the material of the wire. C. In a circuit, two resistors of 5 ohm and 10 ohm are connected in series. Compare the current passing through the two resistors. In a series connection of resistors, the same current passes through the resistance, hence the current will be the same. D. State Joule's law of heating. Write its mathematical expression. Joule's law of heating क्या है? What is Joule's law of heating? When an electric current passes through a conductor, heat H is produced, which is directly proportional to the resistance R of the conductor, the time t for which the current flows, and to the square of the magnitude of current I. Mathematical representation or formula is H equal to I square RT. This is the mathematically represented Joule's law. You can derive this formula by these method. P equal to W upon T. So value of W equal to VQ. When we put up the value of W, so V multiplied by Q upon T, and I equal to Q upon T. When we put the value of I, then we get P equal to VI. So VI is equal to W upon T because P is equal to W upon T. When we put the value of P, VI is equal to W upon T. So we can say W equal to VIT. Work done is energy. So H or heat energy is equal to VIT. When we put the value of V equal to IR, then we get H equal to I square RT. Joule's law of heating. E. How many resistors of 88 ohm are connected in parallel to carry 10 ampere current to 250 volt line? You have to find the number of resistors. Let the x number of resistance are connected in parallel. Equivalent resistance will be 1 upon Rp will be equal to x upon 88. So our value of Rp will be 88 upon x. By putting the formula V equal to IR, R equal to, we put the value of R, 88 upon x will be equal to V upon I. V is 220, I is 10. So we get the value of x equal to 88 multiplied by 10 upon 220. 88 upon 22, and that is the answer, 4 resistors. F. Calculate the highest and lowest resistance that can be obtained by combination of 4 resistors of 4 ohm, 8 ohm, 12 ohm and 24 ohm. For highest resistance, we will connect these all 4 resistance in series manner. So R equal to R1 plus R2 plus R3 plus R4, and that will be equal to 48, not 24, the total of these 4 ohm will be 48 ohm. So answer is 48 ohm. And lowest resistance, when we connect these all 4 resistance in parallel manner, we will get lowest resistance. So 1 upon R equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus 1 upon R4. When we put up the values of 1 upon 4 plus 1 upon 8, 1 upon 12 plus 1 upon 24, we will find out the LCM of 4, 8, 12 and 24, and by adding this we will get 12 upon 24. When we cut these numbers, 12 1 are 12, 12 2 are 24 equal to 1 upon 2 ohm. So 1 upon R is equal to 1 upon 2, so R will be equal to 2 ohm. So lowest resistance will be 2 ohm and highest resistance will be 48 ohm. Question number 2, draw the schematic diagram of circuit conditions of battery of 6 volt, a 5 ohm resistor, 8 ohm resistor and 12 ohm resistors, and key all in series. Calculate the total current in the circuit and potential difference across the 8 ohm circuit. So you have to draw the diagram, schematic diagram of circuit. First of all, you draw the circuit diagram. You have to put the battery of 6 volt and 3 resistance 5 ohm, 8 ohm and 12 ohm you have to connect in series manner. So this is the diagram. Now you have to find out the current flowing through the circuit. So V is given to you 6 volt, R is given to you 5 ohm, 8 ohm and 12 ohm. This will equivalent will be 25 ohm, and formula is I equal to V upon R. When we put up the values of V or R, 6 upon 24, so we will get, when 6 is divided by 24, 0.24 ampere. Now potential difference across the 8 ohm resistor. So V equal to IR, value of I is 0.24, you have calculated, and value of R is 8 ohm. When we multiply it by 0.24 multiplied by 8, we will get 1.92 volt. Now question number 3, first part. B1, B2 and B3 are 3 identical bulbs connected as shown in figure. You have to give in the figure. When all these 3 bulbs glows, a current of 3 ampere is recorded by the ammeter A. Part 1. In part 1, you have to ask what happens to the glow of the other 2 bulbs when the bulb B1 get fused. So your answer will be, when B1 is fused, there will be no influence on the glow of other 2 bulbs, which will remain the same. This is the diagram you have to give in the question figure. Part 2. What happens to the reading of A1, A2 and A3 and A when bulb B2 get fused? When bulb B2 get fused, when the 3 parallel connections, net resistance will be 1 upon R equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Since resistance is the same, so R dash will equal to R upon 3. As per Ohm's law, V equal to IR, so value of R will be 4.5, because the value of I will be 1 and R will be equal to V upon I. So value of V is 4.5, I is 1, then value of I will be 4.5 ohm. Since B2 get fused, so now only 2 bulbs B1 and B3 are in parallel. Net resistance in parallel 1 upon R dash will equal to 2 upon R, or R dash will be equal to 4.5 upon 2 ohm. I is V upon R dash, I is equal to V upon R dash. Now put up the value, I equal to 2 into 4.5 upon 4.5. value of I will equal to V upon R dash. So value of V is 4.5 and R is 4.5 upon 2. We have find out the value of R. This one 4.5 upon 2 ohm. So value of R is this. When we put R equal to V upon I, we have to find out I. So I will equal to V upon R. So we put 4.5 upon 4.5 upon 2. So we will get this one. Now when we put the value and calculate this, we will get 2 ohm. 4.5 will be cancelled by 4 upon 4.5. So we will get the value of I 2 ampere. Third part is how much power is dissipated in the circuit when all the three bulbs glows together. So we know the P equal to power, P equal to V into I. Value of V is 4.5 while the I is 3. When we multiplied 4.5 by 3, we will get 13.5 watt. So power will be 13.5 watt. B part, its B part is what is the commercial unit of electricity of energy and represented in terms of joule. So you know the commercial unit of electrical energy is kilowatt hour. 1 kilowatt hour equal to 1 kilowatt equal to 1000 joule and 1 hour equal to 3600 seconds. So when we multiply 1000 by 3600, we will get 36 lakh joule, and when we in terms of 10 raised to the power, we will get 3.6 into 10 raised to the power 6 joule, because you have put the point after 6. 1, 2, 3, 4, 5, 6. So 10 raised to the power 6 joule. 3.6 into 10 raised to the power 6 joule equal to 1 kilowatt hour. Thanks for watching.